Hey students, now I guess now this is a good news for you. Now from few days we are studying maths, and I might think that you might be a little bored by studying maths only. So here's a little change. Today we are going to study science, okay, and most particularly physics. Now before beginning this topic, I would like to ask that have you ever thought that why we humans we mostly like to do things in the morning or in the daytime, and at night we tend to sleep or take rest, right? We are doing this since ancient times. Have you ever thought? Well, we all know the answer. The reason is simple. It is because of the presence of light, right? Because we can see things in the daytime easily, so we can do other works. But in the night time, it is quite difficult to see things in dark. So we won't do much things, and rather we just take rest. So from this we can conclude that one of the most important things that we receive from the nature is the light. And in this concept, today we are going to see how we see. Okay, so let's begin the topic, light. You have already studied about light in your lower classes, mostly 8th standard, right? Now you have studied something. Let's recall what you have studied in 8th. Okay, so now the first question arises, what is light? So far, what you have learned in your lower class, light is a form of energy which enables us to see. Also in your lower class, you have studied that light travels in a straight line. Okay, so this we have studied in the lower classes, that light is a form of energy which enables us to see, and light travels in a straight line. Now let me tell you something, that light, just like we have our own identity, a different identity. Light has dual identity. Sometimes it's a particle, but sometimes it's a wave. So the general and so far accepted definition for light is that light is an electromagnetic wave. So light is an electromagnetic wave, and this electromagnetic wave, there are different kinds of electromagnetic wave, and just like any other electromagnetic wave, light has a property that it can travel in vacuum. Okay, this is a property which is exclusively found for electromagnetic wave. Other waves, they need a medium to travel, but light, since it is an electromagnetic wave, it does not need a medium. It can move without any medium in vacuum. Okay, and the speed of light in vacuum, or you can say in air, is the height, that is 3 into 10 to the power 8 meter per second. Okay, the speed of light in air or vacuum is 3 into 10 to the power 8 meter per second. That is, in 1 second it can cover 3 lakh kilometers. Okay, so that is the speed of light. Now you have also studied about reflection, right? So what do you mean by reflection? Generally, this is the most important thing which enables us to see. You see, we see an object because it reflects light. Light generally falls on an object, and we see the object because the object reflects light. For example, let us consider, suppose this is a light bulb. Okay, a source of light. Now it is emitting light in all directions. The source is emitting light in all directions. Now here there is an object. Now the light falls on this object, and after falling on the object, the light reflects, or it little bit moves in the other direction. Okay, let us consider this point. So here the light is moving. We already studied light travels in a straight line. So at this point, let us consider these two light rays are coming. Okay, and suppose here is a person is watching. Okay, is watching this light ray falls on our eye, and our eye or the brain, it interprets that where does this light ray comes from. Okay, so our brain moves the light ray backward, and when it intersects at a particular point, then only it forms an image. Okay, so then only our brain identifies that the light came from this object. So we can only see an object when it reflects a light. Okay, so one of the most important phenomena of light is reflection. You have studied about it in class 8. Okay, do you remember? Try to recall what is reflection. Okay, so I guess some of you might have already guessed the definition. What is reflection? Let me tell you. It is a phenomenon So reflection, the phenomenon of sending the light back into the same medium by any object is called reflection. So reflection is a natural phenomenon. As any other natural phenomena, reflection has some laws that it has to follow, and that laws are called as laws of reflection. About this also you have studied in 8th standard. So let's recall. Laws of reflection. There are two laws of reflection. The first law, it states that the incident ray the reflected ray and the normal at the pay attention here, the point of incidence so this is the first law. It states that the incident ray, the reflected ray, the normal at the point of incidence all lie in a same plane. Same plane means on a same, either on a board or a paper, anywhere, but on the same plane, these three lines will lie. And the second law states the angle of incidence is always equal to the angle of reflection. Okay. The second law states that the angle of incidence is always equals to the angle of reflection. Now, you can pause the video and note it down. Okay. So we came to know about the laws of reflection. Now let's understand what basically the laws of reflection states. Okay. Let us suppose this is a mirror. Okay. A plane mirror. Now this side, what you can see are different lines, small lines are drawn. This is the polished surface, and this, the upper part, is the reflecting surface of the mirror. Now you see, whenever a light ray falls on the surface, the light ray, suppose here there is a source of light, and from that source, various light rays are falling on the mirror. But we are considering only one light ray. That ray is called as incident ray. Incident ray. The light ray which falls on the mirror is called as incident ray. What happens? After striking the mirror surface, this light, it undergoes reflection and it bounces back towards the same medium which it goes. This ray is called as reflected rays. Okay? The light ray which emerges out of the mirror is called reflected ray. And this one here, this is the point of incidence. At this point, if you draw a perpendicular to the mirror, here if you draw a perpendicular, this one, it is called as normal. Okay, the perpendicular to the mirror, an imaginary line which is perpendicular to the mirror, is called as normal. So basically, what the first law says is that the incident ray, the reflected ray, and the normal at the point of incidence all lie in a same plane. This is the first law. Now you can see between the incident ray and the normal there is an angle. This angle is represented as small I, and it is called as angle of incidence. Angle of incidence. And the angle formed between reflected ray and the normal, this is represented as R, is called angle of reflection. Okay, this is angle of reflection. Now, the second law says that angle of incidence is always equals to angle of reflection. Means this angle is always equal to this one. Understood? These are the two laws of reflection. Now, moving on. We have studied that reflection mostly, what you observe now, reflection took place in a mirror. The question is, what is a mirror? That must come to mind. Mirror. So, what is the most common answer? That my mirror is something into which we always look our face. We apply some makeup, powder, cream and everything, we comb our hair, that can be a mirror, right? Now that is a general thing. So scientifically, what we can say about mirror? Mirror is generally defined as a reflecting surface. Okay? It's a reflecting surface, or it's a surface which allows light to undergo reflection without any diffusion. In our lower classes, you have studied reflection is of two types. Regular reflection and diffused reflection. So based on that, we can say mirror So mirror is a reflecting surface which helps in the reflection of light without any diffusion. Okay. So now what we see in a mirror, whenever we stand in front of a plane mirror, we see ourselves, right? And that is our image. Now, so the question is, what is an image and how it is formed? So now we are going to study what is an image and how an image is formed. First, image. So, image is a point where the light rays meet or appear to meet. Okay? So, either they meet directly or they seem to appear to meet at that point. That is called as image. Now, in the definition of the image, two things are mentioned. They meet or they appear to meet. So, based on this, image is divided into two types. A real image and virtual image. Real image, virtual image. Real image is something which is formed when the light rays actually meet. Okay, when two reflected rays meet at one particular point, then the image which is formed there is the real image. But when the two reflected rays does not seem to meet at one point, then we extend the two rays in other directions such that it appears to meet. In that case, the image formed is virtual image. Now there are some characteristics of both the image. A real image, they can be obtained on screen, but virtual image we cannot obtain it on a screen. Real image are generally inverted, that is upside down. The real image generally it looks like upside is down. Okay, but for virtual image it is erect. Okay, that is it will be straight, but in both these cases the image will be laterally reversed. That is, the right will appear as left and the left will appear as right. Okay, that is the characteristics of image. Now let's take an example. The same. Suppose we consider a plane mirror. And here is an object. So let's see how the image is formed in this case. Now let's consider, in order for the formation of an image, we need at least two reflected rays. Okay. Now the question is, why we need at least two? Because by definition, image is a point where light rays meet and two lines. In order to meet or in order to find an intersecting point, at least we need two lines. One line with whom it will intersect, right? So we need two lines. So at least two reflected rays are needed for the formation of image. So first we will take, so in order to get two reflected image, we will take two incident rays. First we will take one incident ray at an angle perpendicular to the mirror. Okay, so if this is the incident ray, then the reflected ray also will go along the same path. In the same direction, the reflected rays will move. Now, let's take another one. Here. This is another incident ray. So, we'll draw a perpendicular. This is the normal. So, now, the angle. How much angle it has formed here? With that much angle, the reflected ray will move. Now, this is one reflected ray and this is the other reflected ray. Now, how much we are going to extend, they are never going to intersect in this way. So, what we will do, we will increase the reflected ray in behind the mirror. We try to produce it behind the mirror. So, you can see if we increase behind the mirror, they appear to meet at one point. Okay, and that point the image will be formed. At that point the image will be formed. Since the image is formed by reflected rays, by just seemingly intersect, they are not intersecting actually. So that image which is formed by plane mirror is a virtual image. The image formed by plane mirror is virtual image. Understood? So this something about this you have already studied in 8th standard. Okay. Now moving on to the next concept. Okay, you can pause the video if you want to note it down. Okay, so far we studied about reflection in plane mirror. Now let us consider a spherical reflecting surface. Okay, like a football, completely made up of mirror. Well, that is something which is not found naturally. Just make a guess. Let's take an imagine. Okay, a spherical reflecting surface, which on board is generally will appear circular, right? Now, for a spherical reflecting surface, that is like a ball, if the mirror is in shape of a ball, the image what you will see, okay, at some part it might appear the image will be enlarged or maximized, at some point it will be smaller, right? Now, why it happens? Now, to understand this fact, we will divide the spherical mirrors into two parts, okay? You can say in this case, two reflecting surfaces can be seen. We will make a perfect here. Okay, two curves. So in this case, we will see that two reflecting surfaces can be found. The two reflecting surfaces are called concave and convex. Now let's understand it properly. What does this line mean? This term, concave and convex. Let's move it. Concave mirror. Spherical mirrors are actually divided into two types: concave mirror and convex mirror. So, concave mirror. Concave, the word itself includes cave. Okay, means imagine something going inside a cave. This is the structure for a concave mirror. The outer surface, that is the bulging part, is generally polished. Okay, and the inner surface, which is cave, okay, that is the reflecting surface. So light appears like it is going inside a cave. So that's why the name is given, concave mirror. So that it will make it easier to remember. Okay, most of students they get confused that which mirror is concave and which one is convex, and the opposite is convex. Okay, if the inner surface, if you take it as a reflecting one, the polished one, and the outer is a reflecting surface, then this one is called as convex. This is called as concave. Okay, concave mirror, convex mirror. For example, if you take a spoon, right, the outer surface of the spoon, will behave as a convex mirror. The inner surface it will behave as a concave mirror. Okay, now let's start with concave mirror. Okay, concave mirror can be defined as a part of hollow sphere having its outer surface silver and inner surface as a reflecting one. Okay. Now, this is concave mirror, right? Convex mirror. This is concave mirror and convex. It is also part of hollow sphere. Having its inner surface silver the reflecting surface. Okay. Now, these are the basic definition for concave mirror and convex mirror. Now, let's see some of the terms that is related to the spherical mirrors. First is center of curvature. Center of curvature. Now, as we discussed, that these spherical mirrors are part of a sphere, and we know that sphere or in two dimensions a circle has a reflecting it has a center and a radius. So similarly, the center of the sphere from which these mirrors are derived or a part of that center is called as the center of curvature. So you can write it is denoted by center of curvature, the center of sphere of which the spherical mirrors are formed or a part of. That center is called as the center of curvature. It is denoted by C. Okay. Now pause the video and note it down. So the next term that is related to spherical mirror is the radius of curvature. Well, to understand this, it is quite easy. We all know what is a radius, right? Radius, the distance from the center to the circle, to the circumference of the circle, is called its radius. Similarly, for a sphere also, we can tell the same. So, similarly, the distance from the center of curvature, the distance from the center of curvature to any point on the mirror. Mirror, here it means spherical mirror, is called radius of curvature. It is denoted as capital R. Okay. So radius of curvature is the distance from the center of curvature C to any point on the spherical mirror. Either it may be concave mirror or convex mirror. Now the next term is pole. Pole is nothing but just the center or central part of the spherical mirror. of the spherical mirror. It is represented as P. Okay. Next, principal axis. Principal axis. It is an imaginary line passing through C. What does C stands for? Center of curvature. So C to the pole P of the mirror. Of the mirror. Okay, so principal axis is not an actual but an imaginary line which passes through the center of curvature and meets the mirror at pole. Now, the other term is principal focus. Principal focus. Before to understand what is principal focus, we need to know what is focus. Okay. Generally, we have done a lot of times when we click a picture. Sometimes when you are going to click a picture and you have to fix or you have to take the picture of a particular object, you generally touch that and such that the camera, it points at that object or it focuses on that object. So there, what we do? We focus on that particular point. So what does focus means here? It means for a spherical mirror, focus is a point. Focus is a point at which the reflected rays which originate from the incident rays which are parallel to each other, parallel incident rays. If the reflected rays that are generated from the parallel incident rays, they meet at a point or they appear to meet at one point, that point is called as focus. And if the focus lies on the principal axis, it is called as principal focus. Okay. So this is concave mirror. Okay. And this one is convex mirror. As you can see, for concave mirror, okay, the circular part will form this side, so the center will be here. In this direction before the mirror. In case of a convex mirror, it will form a circle. So the center part will lie behind the mirror. Okay. So notice this, that for a concave mirror, the center of curvature lies before the mirror. But for a convex mirror, the center of curvature lies behind the mirror, after the mirror. Okay. This distance from center here to pole is called as radius of curvature. This distance is called radius of curvature. Okay. Now let's see what is focus. So let us consider parallel rays. Some parallel beam of rays. Yeah. For a concave mirror, it was observed that parallel incident rays, after reflection from concave mirror, they all intersect at one point. They all intersect at one point, and that point is called focus. But for a convex mirror, they won't intersect at one point. Rather, they will diverge as if they are coming from one point. Okay, and that point from which they are likely to appear, that point is called as focus for convex mirror. And since the focus lies on the principal axis, it is called as principal focus. Okay, so understood what is principal focus? And the distance between focus to pole is called as focal length. Okay, the distance between focus to pole is called as focal length. Understood? Focal length, the distance between focus and pole. So here we have two distances. One is the radius of curvature, that is distance from the center of curvature to pole, and other is the focal length, that is from pole to focus. So there is a high possibility that there might be a relation between focal length and radius of curvature. Before moving on to the relation, pause the video and note it down. Okay, so now we can see here the diagrams of two mirrors, that is concave and convex. Okay, like we discussed, so we came to know about two quantities that is used to measure distance, right? Two distance related quantities in spherical mirror. One is the radius of curvature, which is the distance from center of curvature to the pole. It is represented as r. Okay, and another is the focal length, that is the distance from focus to pole, and this is represented as small f. This quantity is represented as small f. Now since these two both are related, are a type of distance, they have a relation between them. And what is the relation? The relation is that the radius of curvature is twice the focal length of a mirror. Okay, the radius of curvature is twice the focal length of a mirror. If the focal length of a mirror is 15 centimeter, then the radius of curvature is going to be 30 centimeter. Understood? Okay, so this is the relationship between radius of curvature and focal length. Okay, so I guess this much will be enough for today. You guys might be bored if you go on more. So this is for now. Learn all the terms related to spherical mirrors properly and understand it properly, because it is going to be highly essential to understand the next concept, what you are going to study in the next video. Okay, so this is the homework for you. Study and memorize the laws of reflection, and study and understand all the terms related to spherical mirrors. Okay.